So the one piece that is helpful in looking at that video is the fact that when a company has heavy fixed costs, the ability for them to make a massive amount of money is great. But if they don't meet their break even, the ability to lose a massive amount of money is great. So when we're dealing with companies with fixed costs, a barrier is to get into the market because the fixed costs are so great. How many of us can just go and open up an automotive factory? It's not going to happen. It's heavy in fixed costs. So companies such as airplane manufacturers, automobile manufacturers, utility companies, they can make a lot of money, but the barriers to get into that kind of market are really tough. You need a lot of money for those fixed costs. On the other hand, when companies have a lot of variable costs, it's easier to open into that company because you don't need quite the capital to enter in. But when a lot of your costs are sitting in a variable manner, as you make more products or make more money, you know, you've got that net profit per item still. It's not going to skyrocket because the costs are variable per unit item. Make sense? So with cost profit analysis, the interesting thing is to really understand where the break even happens. When you increase above that break even, when you're heavily involved with fixed assets, your profits soar. When you're heavily involved with variable types of costs, they're definitely going to increase, but not at that same level. One is riskier than the other. Heavy fixed costs have a heavier risk factor because when companies are not doing as well, such as the airline industry a couple of years ago, what happened when the airline industry was hurting? What happened, guys? How many filed bankruptcy? But then what happens like right now? They're going gangbusters. It's so volatile. Okay? That can be the negative. Look at GM. And I'm not trying to just look at it on just the economy. There's a lot of factors involved with companies being successful or not. So I don't want to even minimize the complexity of it. But generally when the sales volume reduces, companies with fixed costs like that are in trouble. So there's a trade-off. And it makes you, I guess what I'm trying to help you see is understand why not everyone just jumps into heavy fixed cost. It's cost prohibitive. Okay, guys, we are going to pick up on this chapter. I'm trying to think where we
left off at the target net income.
The target?
Yeah, we're almost done.
Margin of safety, break even. Margin of safety. Target net income. Okay, so we're going to start now with looking at, in CVP, cost volume profit analysis, we get to find out the break-even point. What do we need to produce just to break even? But we want to do a lot more than just break even, don't we? We want to bring in some money. So we can decide on our targeted net income that we would like to make, and then from there determine what we need to produce in order to make that targeted net income. So for example, in this equation, we can have a required amount of sales less our variable and fixed costs to determine our target net income. So, of course, sales need to be increased in order to determine that net income because the variable costs are going to be based on each unit and our fixed costs, of course, are going to be fixed within that relevant range. So if we use this formula and we say we want to have sales of $500,000 or $500, we figure out our $500 quantity minus our variable costs are going to equal our fixed costs plus our target net income. So if we look at here and we use this formula, we determined that we need to make or sell 1,600 units at $500 per unit in order to hit our target net income. We'll work on some problems like this so we can see it flesh out in real practice. To determine the required sales in units for the Vargo video, we're going to look at our fixed cost plus our target net income, divide that by our contribution margin per unit to determine we need 1,600 units. So we can determine our target net income in both fashions, in overall sales or in units. Here, if we deal with it in dollars, we take our fixed cost plus our net income, divide that by this contribution margin ratio. After our variable cost, what we have left in order to apply towards fixed cost plus our income to come up with how many dollars in sales we need to come up with. The mathematical equation for computing required sales to obtain target net income is required sales equals variable cost plus target net income, variable cost plus fixed cost plus target net income, fixed cost plus target net income. None of them are correct. Bless you. We need to account for our variable cost. We need to account for all of our fixed costs, and we need to make sure we have our net income in there to determine how many dollars of sales we ultimately need to produce. Now there's this margin of safety we're bringing in, this new term in this chapter, which is the actual sale or the expected sales, and then sales at the break-even point. So it's a safety valve because we want to, this is the zero, where we break even is zero income, no loss. And then that difference is going to be our margin of safety. So that's basically that cushion in case something doesn't occur the way we plan on it. Again, just like in the other formula, we can express it in terms of units or sales. Our expected sales are going to be at 750,000. Our break even is at 500,000. So our margin of safety in dollar amount is going to be 250,000. If we decide to do it based on a ratio, we can take our 250,000, the dollar amount, divide that by what we anticipate our sales to be to determine our ratio of the percent margin of safety. The higher the dollars or the percentage, the greater the margin of safety, the greater the cushion we have. Marshall Company had actual sales of 600,000 when break-even sales were 420. What is the margin of safety ratio? So what is our cushion? Our cushion is 180, right? Our cushion of 180 divided by our 600,000 actual sales. 420, 180. Am I doing that wrong? Yeah. Is our margin of safety ratio. So the 180 is what the extra safety zone is. Divide that by our total actual sales, gives us our safety ratio of 30%. Okay, let's look at this one. Zoot Suit makes travel bags that sell for $56 each. For the coming year, management expects fixed costs to total $320,000 and variable costs to be $40 per unit. Compute the following: the break-even point in dollars using the contribution margin, the margin of safety assuming actual sales are really $1,382,400, and the sales dollar required to earn the net income of $410. So the first thing we need to do is determine the break-even point in dollars using the contribution margin ratio. How are we going to begin to do that? We're selling them for 56. Our variable cost per unit is 42. Therefore, we have $14 a unit to apply towards our fixed costs, don't we? So if we take our $14 per unit to divide it by our sales price, then 25% of the sales price gets applied towards the fixed cost. If our fixed costs are at $320, then we divide that by 25% to determine what we really need to sell in order to break even. This is just to break even, 0. Then, if we take our margin of safety, we get what our actual sales are minus what we determined our break-even sales are to come up with our margin of safety. We divide that by our sales to come up with our ratio of 7.4% is our ratio of, or the cushion between our break-even and what we expect our sales to be. Then if we, in order to compute the dollars required, if our fixed costs are at $320 and we want to make $410,000, then we do our contribution margin to determine how many dollars of sales we really need to make. Any questions? It's always helpful to go through problems. We'll be careful how many problems we go through today. We'll do this in a problem because you can look at these PowerPoint and review this, but we'll go through these problems. Okay. Any questions? Any questions at all? So, we started with, I think we did some of these on Tuesday. Did we go over 5.4 and 5.5? Yes, we did.
That's a 5.8.
We finished 5.8. So we'll work on problem 5.1. Do you guys feel like this chapter's fairly easy or fairly understandable? Isn't that nice? Okay, so I'm going to pull up the Course Smart. And what page are we on? 220? 227. Thank you. Okay. 5.1. Telly Savalas owns the Bonita Barber Shop. He employs 4 barbers and pays each a base rate of $1,000 per month. One of the barbers serves as the manager and receives an extra $500 per month. In addition to the base rate, each barber also receives a commission of $4.50 per haircut. Other costs are advertising, then there's rent, barber supplies, utilities, and magazines. He's currently charging $10 per haircut. So, we need to determine the variable costs per haircut and the total monthly fixed costs. So how are we going to start in determining variable costs? Let's just look at this. What are the variable costs? Do you think the commission of $4.50 per haircut's a variable cost? What else is a variable cost? Barber supplies, 30 cents a haircut. Some utilities, 20 cents a haircut, aren't they? So let's look at this. Variable cost per haircut, our commission is how much? $4.50. $4.50. Our supplies, barber supplies, 30 cents. Okay, let me see what I'm doing wrong here. Ah. $4.50. Then our supplies, 30 cents. Then utilities of 20 cents.
175 plus.
I'm sorry.
Oh, just per haircut. It's 175 plus the 20 per haircut.
Right, but these are just the variable costs we're looking at.
Okay.
Okay? So we've got variable cost of the $4.50, the 30 cents and the 20 cents. Our total variable cost per haircut, $5 a haircut, aren't they? So that's the amount we know that we have per haircut. That it's just going to happen per the cut. But now we've got a bunch of fixed costs. What are our barber salaries? Bless you. 4,000. What's our manager's salary? Extra 500. Darn it. What's our advertising? Darn it, I'm telling you. There. Our advertising is 200. Our rent, 1,100. Our utilities, because that's the fixed portion, fixed cost portion of the utilities. And then our magazines. So what are our total costs here? $6,000. So our total costs here are $6,000. So now we need to still move on and figure out what is the first problem we need to do? I think we did it. Let's see. The first portion asked us to determine the variable cost per haircut and the fixed monthly cost. We did that. Now they want us to compute the break-even point in dollars and in units. So to break even, we need to then determine the amount of haircuts we need to break even or the dollars amounts. So our costs are what? How much do we pay for sell a haircut for? $10 times the number of haircuts are going to equal our variable cost times each haircut plus our fixed cost of $6,000. We're going to have, if we carry this out, we'll have our 5x equal $6,000. So x means we need to have 1,200 haircuts. And if we have 1,200 haircuts at $10 a haircut, we'll make $12,000, won't we? How you doing? Now, as we move on, it asks us to plot, prepare a cost, volume, profit graph, and assuming a maximum of 1,800 haircuts in a month, use increments of $300 haircuts on the horizontal axis and 3,000 on the vertical axis. So I gave that to you. As you can see here, we have a fixed cost of $6,000 a month. And then from there, we come up with where our break-even point is. And you see, based on the dollar volume, here's our cost, here are our sales. Here's where we break even. $12,000, 1,200 haircuts. So everything above this is profit. Everything below this is loss. Any questions on this? Let's see what D says. Determine net income assuming 1,700 haircuts are given in a month. How are we going to do that? We can start with 1,700 haircuts at how much a haircut? 1,700 haircuts, 17,000, excuse me, minus, what are our variable costs? 1,700 or so 17,000 is what we want to, our sales will be, minus 1,700 units or cuts times $5 a cut, plus $6,000 in our fixed costs, right? So won't our net income equal, what do you think? $5 times 1,700 is what? I'm sorry? 8,500. 8,500 plus 6,000 is 14,500, right? So net income ultimately is going to be 2,500, right? Any questions on that?